Hey, it's Workbench with Workbench Quagmire, back with day 72 of our free code camp Python certification in 100-ish days. Today, we're going to tackle the workshop in this section on linear data structures. We're going to build a linked list. So if you remember, a linked list is a set of nodes that have a reference to another node. So a singly linked list has a reference to the next node, or the previous node, I can't remember. And the doubly linked has both previous and next. That way you can traverse in both directions. So let's just jump right into this and then see how far we can get through it. Step 1, in our previous lesson, you learned about common data structures. In this workshop, you'll implement a linked list. First create a class named linked list to represent the structure that will hold your list nodes. Add the pass keyword inside the class so you can test, so the test can pass. So inside your linked list class, replace pass keyword with an inner class called node. This will represent individual nodes and store the data in the list. So you have to put pass in here as well. There you go. Next, remove the pass keyword inside node and give the node class an init method with two parameters, self and element. Inside the method, assign element to self.element. This stores the value passed when creating the node. Still inside the init method, assign none to self next. This sets the next pointer to none, meaning the new node does not yet point to any other node in the list. Later, next can be updated to point to another node to form the chain of linked list. Inside the linked list, add an init method that sets self length to 0 to self length to 0. This initializes a counter to track how many node elements are currently in the list. Still in the init method of the linked list class, set self head to none. This acts as a reference to the first node in the list. The list is empty at the moment, so you have to set it to none. Add a method called isEmpty that returns self.length equals 0. You'll use this to keep track of how many nodes are in the list. So if self.length equals 0 returns true, then it means it has no nodes. If it has anything greater than 0, it'll return false. So step 8, let's test your linked list so far. At the bottom of your node, create a linked list called myList. And then using the isEmpty method to create, you created in the last step, print mylist.isEmpty. So now, after the isEmpty method, create a method called add inside your linked list class. The new method should have two parameters, self and element. Inside your new method, create a variable named node and assign it to the new instance of node by using self node and element. This will create a new node to be added to the linked list. Step 10, if the list is empty, then the new node becomes the first element, the head. Inside the add method, create an if statement that checks if the list is empty using else or is empty and assign node to self head. So, Step 11, if the list is not empty, the method should find the last node and link the new node to its next pointer. To do this, create an else block after your if, and inside the else block, create a current node variable. Node variable and assign self.head to it. Still inside the else block, create a while loop that checks the current node dot next is not none. Inside the while loop, assign current node dot next to current node. Step 13, while the while loop you've just created enables you to go through each node in the list until the last node is reached. Once that happens, you can add the node to the list. In the else block, right after the while block, assign node to current node next. Block. Go. After adding a new node to the list, you'll need to update its length. At the end of the add method, increment self.length by 1. Step 15, great. Now let's test adding elements to your linked list. At the bottom of your code, after creating a instance of linked list called mylist and printing mylist is empty, add 1 and 2 to the list using the add method. Then print mylist.isEmpty again to confirm that the list is no longer empty. Finally, print mylist.length to see the current length of the linked list. So there we go. It's no longer empty and it has a length of 2. Step 16. Next, you're going to create another method that will be used to remove an element, a given element from the linked list. Create a method called remove with 2 parameters, self and element. Inside it, create a variable called previous node and assign it to none. Inside the remove method, create a variable named current node and assign it to the value of self.head. This starts the traversal of the linked list from the first node. Current node will be used to keep track of the node currently being examined as you look for the node containing the specified element to remove. Step 18. Next, you'll loop through the linked list to find the node that contains the specified element to remove. Create a while loop that checks the current node is not none. And when current node.element is not equal, let me do this. Some parentheses. And current node.element is not equal to element. Inside the while loop, assign current node to previous node. Next, assign current node next to current node in the while loop. After the while loop, create an if statement that checks if current node is none. When this happens, the linked list has been traversed without finding the element to remove, and the function should stop running. Therefore, add the return keyword inside the if body. So this is just return. Step 21. Next, create an elif statement that checks that previous node is not none. Assign current node to previous node next. With that, the element to be removed is found and it's not in the head node. The next pointer of the previous node will be updated to skip over the current node, the element to be removed, removing it from the linked list. Next, create an else block. That assigns head is assigned current node next. This handles the case where the element to be removed is found in the head node. By updating self.head to point to the current next node, the head node is removed from the linked list. Step 23. At the end of the remove method, decrement self.length by 1. This decreases the length of the linked list to reflect removal of the node. Now let's test removing an element from your linked list. At the bottom of your node of your code, remove one from the list by using the remove method, then print the length again to see the length updated. With that, the linked list structure of the workshop is complete. So my list dot remove one, print list length. There you have it. It's now 1. All right. Next time, we don't cover these things here. Next time, I'll probably just go over the build a hash table certification project after I've completed all the code. That's another one of those I've gone through it, and it's not really something you can recreate in a different way. So I'll be just making one video about that, and then we'll continue into algorithms here. And with our theory sections, I don't think there's very many. It's probably one day here. And then we just have a lot of workbenches and labs. Yeah. So these are one day, and then one day, probably one day, probably one day. So we'll move through these 1, 2, 3, 4, 5, 6 days, 7. So that's like a week. We're getting close to the end here. So just got a few more weeks. So thanks for watching the video. Don't forget to comment, like, and subscribe, and I'll see you next time.